Hello there. My name is Nur Shafinaz Q5. This is my metric number Bs17110227. So this is the question test 5, and this research question states that whether the body height of student related to the state and genders. So let's check it out. If the research question is the same as I am. So we move on to the next slide. So this is the new research question. Actually, the research question is more likely the same. So, is there any difference in body height between male and female student in UMS between Sabah and Sarawak State? So, this is the data summarization. So, in this data summarization, 12 samples from 12 students is being collected. One dependent variable being recorded, which is the body height, while one categorical variable with two group of state of Sabah and state, and also another categorical variable with two group of gender of male and female. So this is the experimental design. So for grouping, we have two state, Sabah and Sarawak, and gender, female and male, and one sample for both grouping. So for each sample size is consists of 6 students. So the body height was obtained from each student. So this is the box plot that we use to summarize and compare data from 2 or more samples. So we have x-axis gender and state. We have body height as the x-axis. So this is the title, body height of female and male student in UMS between Sabah and Sarawak State. So by using box plot, we can determine whether there are significant difference in body height between male and female student in UMS between Sabah and Sarawak State. So for normality and homogeneity of variance, normality have normally distributed because all the p-value for all the data is larger than 0.05. So when larger than 0.05, so we do not reject H now. So that is normally distributed. So for homogeneity of variance, the homogeneity variance is also larger than 0.05. So it does not have significant difference. So the variance of sample is equal. So for the test, we use two-way ANOVA test because we want to compare mean across more than two groups. So the data type, we have two independent variables and also one dependent variables. Two independent variables. So the assumption whereby homogeneity of variance must be equal, independent of observation, means and the next one is normally distributed dependent variables. Okay, so the criteria is alpha is 0.05. So this is a two-tailed test. So hypothesis, null hypothesis, there is no effect of gender on the body height of the student in UMS. Alternative hypothesis, there is an effect of gender on the body height of student in UMS. So null hypothesis, there is no effect of state of faculty on the body height of student in UMS. Alternative hypothesis, there is no effect of state of faculty on the body height of student in UMS. So the next one is there is no interaction of gender and state on the body height of student in UMS. Alternative hypothesis, this is error, there is no interaction of gender and state on the body height of student in UMS. So the conclusion is, so in two-way ANOVA interaction, the p-value is 0.554 is larger than the alpha value 0.05. The null hypothesis is not rejected. There is no significant difference between state. The p-value 0.176 is larger than the alpha value 0.05. The null hypothesis is not rejected. So there is no significant difference between gender. So for two-way with interaction, the p-value is 0.176 is larger than the alpha value 0.05. The null hypothesis is not rejected. There is no interaction between the state and gender. So we move to R. So we must set the directory and run. We must log the object, gender state I, and the file must be in CSV. So we structure gender state, summary, we combine factor with the object, gender, and also state, and run. We enzyme the com factor. Now we try to combine this one. So next we set subset for each of the data. So we run. So the next one is Shapiro, is to study the normality. Actually for Shapiro test, female Sarawak body height, I have problem, so cannot be read. So all the test is considered as more than 0.05, which is indicated as normally distributed. So we move on to lagging test. So we run library. So this is more than 0.05, so indicate that it's equal. So box plot to summarize and compare data. So this one. So this one is without interaction. Run. Run. This is data. So we run. This is with interaction. So I think that's all because time is running out, sir. Thank you, sir.